right, we're going to talk about chapter 8. So this is our solutions. We're going to use a bunch of the stoichiometry that we just used in chapter 7 as well. Let's talk about what makes up a solution. All right, so a solution is a homogeneous mixture, and there's two components to it. There's what we call our solute and our solvent. The solute is the one in lesser amount, and the solvent is one in greater amount. Generally speaking, we're going to talk about our solvent being water. So looking at things that dissolve in water. Solution concentration, we have what we call a dilute solution or a concentrated solution. So a dilute solution is when I have a really small amount of my solute compared to the solvent. So this would be like a little bit of salt and a whole lot of water. A concentrated solution is where I have a large amount of my salt dissolved into my solvent. Okay, and here's just an example. If you look at what we have here, we have sodium chloride, which is just table salt, and putting it into this volumetric flask, and then we add water to it. What happens to the salt? It dissolves. And if I can put a lot more salt in here to dissolve, then I have a dilute solution. If I can't, for it to not continue to dissolve, then I have more of a concentrated solution. We measure concentration in something called molarity. So molarity is a concentration unit. It's symbolized with a capital M, and it is the amount of solute in moles divided by the volume of solution in liters. So we may have something that we know is 1.0 molar. Oops, sorry about that. And then that means that I have 1 mole of my solute divided in 1 liter of solution. So we're going to look at measuring molarity. So I have these in the slide that you could work this out. You're going to need your calculator. And so here we go. If I dissolve 25.5 grams of potassium bromide in enough water to make 1.35 liters of solution, what is the molarity? So here, what we're dissolving, this is our solute. And then this is how much solution we have. So remember that molarity equals, I'm actually going to do this a little differently. All right, so we're given the mass of the potassium bromide in the liters of solution. We want to find the molarity. All right, so what we need first is, do we have to do any converting? We do, because remember, molarity is moles of solute. So I need to figure out how many moles of potassium bromide I have. And so it's a simple grams to mole calculation. You're going to use the molar mass. So we'll go from grams to moles of our potassium bromide using the molar mass. You would calculate that. You guys should be well versed in that at this point. And then I can take my moles of my solute and divide it by the liters of solution. And I'm given the amount of solution already in liters. So we'll have our moles of potassium bromide. So I'm going to, again, use my molar mass in that conversion. So I have 0.214 moles. I'm given the liters, so I'll take that 0.214 moles and divide it by the liters, and this would be our molarity. Now, when we solve for molarity, we will put our solute after the M. So it's 0.122 molar potassium bromide. And what that means is for every 1 liter of solution, we have 0.122 moles. Okay. All right, let's look at another one. Here we're going to calculate the molarity of 45.4 grams of sodium nitrate. by dissolving it in solution or dissolving it into water, that gives you a total volume of 2.5 liters. Bear with me for 1 second. So what's the first thing we need to do here? We need to find out how many moles of sodium nitrate that we have when we have 45.4 grams of it. So what are we going to do? We are going to add, or excuse me, we're going to take the molar mass of sodium nitrate. That's going to be our first step. Oops, sorry about that. Let's just stay here. We're going to take our mass of sodium nitrate, or my mouse is being funny, sorry, grams of sodium nitrate. We'll turn it into moles of sodium nitrate using the molar mass, and then take whatever you get for that, your moles, and divide it by 2.5 liters. So I'm going to have to come back to this one when my mouse is not being crazy. All right, so molarity we can also use in calculations. Here, we can set up, if we know the molarity of something, we can set it up into a conversion factor. So if we have a solution that's 0.5 molar sodium chloride, that means we have 0.5 moles of sodium chloride per liter of solution. So you can take that and put it in fraction form. That allows us to convert between liters and moles. You can flip it. If you want to find moles, it's going to be like this. If you want to find liters, it's going to be like this. But that ratio will be maintained. So let's look at this one. All right, how many liters of 0.125 molar sodium hydroxide contains 0.255 moles of sodium hydroxide? All right, so what are we given? We're given the concentration, and we're given moles of our solute. And we're looking for liters of the solution. So I can take my molarity, and I can put that into a conversion factor. Okay, and that conversion factor will look either like, well, it's going to look like this in this case because I'm solving for liters. It'll be 1 liter over 0.125 moles, or if you were solving for moles, it would be flip-flopped. Okay, so this is that relationship. We're just going to flip it because we're going to look for liters. Okay. All right, so what I'm going to do is take what I'm given, the moles, I'm going to multiply it by that ratio, and we'll get 2.04 liters of solution. So these moles cancel, and we're left with liters. All right. Now, sticking with molarity, we're going to use molarity to make a solution. And what I mean by that is if we have a starting solution that has 18 molar, let's say, and we want to make a solution that is 2 molar, and we want to make 500 milliliters of it, there's going to be a methodology for us to use. And to do that, that process is called a dilution. So we take something that is higher in concentration and take it to something lower. We're diluting it by adding more of our solvent. And in this case, our solvent's really just going to be water. And so this is what we're going to use. This formula right here, M1V1 equals M2V2. M stands for molarity, V stands for volume. This is initial molarity, initial volume, final molarity, final volume. So if we want to do a dilution, we can use this. We're going to look at that relationship. If I have an initial molarity and I know what molarity I want to make and how much of it I want to make, I can calculate how much of the initial one I need. Okay, so for example, I want to prepare 3 liters of a 0.5 molar calcium chloride solution. But I'm starting with a 10 molar calcium chloride solution. The stock solution is your more concentrated solution. So to do that, I want to figure out, okay, well, how much of that 10 molar stock solution do I need to add, or how much water do I need to add in order to get to 0.5 molar? So we are going to just go ahead and to solve that, we're going to plug this in. So we have an initial concentration of 10. So we see that here. You don't need to put this in, you can just put this as 10 molar. The volume, we want to know how much volume. Actually, I guess this is telling you this. If we didn't have this yet, we know what we want. We want 0.5 molar. We want 3 liters of it. So I could plug all that in and then solve for my initial, and you would get 1.5. So then, or 1.15 liters. Then what I know then is I need to add 0.15 liters into the 3 liters and fill the rest with water. Okay, so let's look at this example. Anytime I have a dilution, you're going to use that M1V1 equals M2V2. To what volume should you dilute 0.2 liters of a 15 molar sodium hydroxide solution to obtain a 3 molar sodium hydroxide solution? All right, so I have a an M1, a V1, an M2, and I'm solving for V2. Right? So an initial concentration, an initial volume, a final concentration, and I'm looking for my final volume. All right, so I'm going to plug it in. All right, so to solve for my final volume, if I rearrange it ahead of time, I'm just going to plug in my 15 molar, my 0.2 liters, and my 3 molar, and I get 1 liter. So that means that in order to get to the smaller concentration, I need to change the liters from 0.2 to 1. So you will add enough water in there to get it to 1 liter.